In this lesson, we're going to look at the sine law and non-right triangles. So our objective is to be able to solve non-right angle triangles using the sine law. The sine law, or the law of sines, is different than SOHCAHTOA. So one of the key things to note is there's certain things we can only use with right triangles. So right triangles are the only kind of triangle that has a hypotenuse. Okay, so that's something, this is really key to remember. Because they're the only kind of triangle with a hypotenuse, we can only use Pythagorean theorem for right triangles, and we can only use SOHCAHTOA for right triangles. And the reason for that is they have hypotenuse, hypotenuse, and then opposite and adjacent. It doesn't have hypotenuse in there, but it's implied that the hypotenuse would be there. So we can only use those four equations if we have 90-degree angle. So, okay, so that's really, really, really key to remember is we must have 90 degrees. If we don't have 90 degrees, you cannot use any of these. So what do we use when we don't have a right angle? Well, there are some things that apply to all triangles. One thing that applies to all triangles is the sum of the angles will always add to 180 degrees. That's a rule that will always exist. Another law that always applies to all right triangles, right triangles and non-right triangles, is the sine law. And the sine law gets written out, it uses sine, but we don't have the words opposite and hypotenuse with it. So we're going to say the sine of angle A divided by the side A is going to be equal to the sine of angle B divided by side B, equal to the sine of angle C divided by side C. Now we can take that, it's a ratio. You'll see it's a ratio with 3 parts instead of a ratio with just 2 parts. We will only ever compare 2 pieces at a time. So you might compare A and B, you'll compare B and C, but you won't compare all 3 at once. They're all equal to each other. Now you can write them with the angle on the top and the side on the bottom, or we can flip it and we can write the side on the top and the angle on the bottom. And often what I'll say is if you're not sure which way to write it, you know how to rearrange for both, so you should be able to use both. But if you're looking for the angle, put the angle on top. If you're looking for the side, put the side on top. And they're always going to be in matching pairs. Now, how do we decide what is side A and what's angle A? Well, we use the geometry method of naming our triangle with letters. And when you do that, here's angle A. Side A is opposite, okay? Angle B, side B, we label it with a little b, is opposite. And same thing for C. You have angle C and little c is opposite. So this compares opposite sides. So it compares the angle with opposite side. Now, if we were doing this with a right triangle, the same math would work, but what's happened over here is we find that the sine of 90 degrees is equal to 1, so we don't actually include that angle there, and that's why these are basically like a shortcut version of this longer equation. Now, one important thing to note before we go on is we're going to use this sine law ratio. The cosine law is very different. You can look it up in your textbook. I've given you the pages. You'll find it in page 459 to 470, so you'll find it in that range, and you can look it up there. But it's much more complicated, and it's not on our syllabus. It's an item we need to complete, so we're only going to cover the sine law. All right, so using the sine law, some easy calculations to get us started. It's a nice simple ratio, not too complicated. So it says, given the 2 angles and side in the image below, determine side x of the oblique triangle. The dimensions are in inches. Now, one of the things to notice here is you'll see here, this looks like a right angle. So if you're not sure, calculate it. 180 minus 58 minus 36. What do you get? 86 degrees. So it looks close to a right triangle because it is close, but 86 degrees is not 90. So this, even though it looks like a right angle, is not a right angle. All right? So just watch for that. Sometimes it will look close in an image. Now we want to figure out, well, what is side X? So let's first label our triangle with A, B, and C. So it doesn't matter which one we call which. I'm going to say A, B, C. Now I've got to label the sides. So little c is opposite the big C, little b is opposite big B, and little a is opposite big A. So we've got our sides all labeled, and we're going to use the law of sines. So the sine of big C, I'm looking for a side, so I'm going to put the side on top. So side divided by the sine of the angle is equal to, and in terms of what I'm looking for C, and I have a pair that uses A. So we're going to use C and A. I always look for a pair that we know information about. B, we only don't know two pieces of information, so we can't use B. But for C, we know the angle and we want the opposite. And A, we have the angle and we have the opposite. So it always kind of makes this X pattern. So putting in our information, we'll put X where C is, and the sine angle C is 36 degrees, is equal to, little a is 3.5, and the sine angle A is 58 degrees. Okay. So easy calculation. Now, you can solve this two ways, and if we set it up this way, it makes it easier for a calculator. You can use cross multiplication and division. So 3.5 times sine 36 divided by sine of 58. You can use cross multiplication, that's perfectly allowed. But if we do rearrange, you have x divided by sine 36. So if we do times sine 36, so if you do one side, you do the other, we get x is equal to 3.500 divided by the sine of 58 times the sine of 36. So it makes an easy calculation for us. Our calculator can actually handle this all in one step if you would like, but if you're not sure, calculate each component separately. What I ended up with is 4.12712 times the sine of 36. I did write it down with a few extra steps just to help you out. And then I multiplied that out and I got x is 2.426 inches, or 2 and 426 thou. Okay, so that's finding our side. We don't have to find B. We don't really care about B. We could have eliminated that completely. That answers our question. And one of the ways to check and see, did you answer the question, says determine side X. So that has us finished. So just watch. Sometimes it's easy to miss if there's another step, but that does have us complete. This one says given two angles and a side of the oblique triangle shown. Oblique means it has an angle greater than 90 degrees. Determine all the missing sides and angles. Dimensions are millimeters. So in this case, we want to find A, we want to find B, and we want to find angle A. So labeling our sides, little b is here, the angle opposite is going to be there. So that must mean this is C and this is little c. I would suggest calculating angle A first. We know that all the sides in a triangle add to 180 degrees. So we can easily find out what angle A is. If you subtract 37.3 and 24.5, we get ourselves a value of 118.2. I like to put it in here. Degrees for A. They're all in one decimal place. We'll give our answer in one decimal place. So we just finished off one piece of the puzzle. Now we need to find out the length of little a, the length of little b. So let's find little a first. So little a divided by the sine of the angle is equal to one of the other pairs. So which other pair do we know? Well, I have a length for C. It's the only side. So do I have angle C? Go across, there's the angle, and we do. So we're going to use C. So 108.60 divided by 37.3. Just make sure I leave the sign in there, sign of 37.3. Just make sure you're using an opposite pair. So angle and a side opposite. If you rearrange that, and I'm going to let you do the rearranging this time, you will find A is equal to 108.60 divided by the sign, 7.3 times sine of 118.2 gives us a length of 157.94 millimeters. So that's our A. Easy calculation. B, we're going to do exactly the same way. These are little underlined so we can see what they are. To find B, little b divided by, okay, there's B. Angle B is 24.5. Is equal to, and let's use the pair for C too, because we know we don't have a miscalculation there. So 108.60 divided by the sign, 37.3. I could use A as a pair, but I've calculated two things for A. So what if we made a mistake? It would just make extra mistakes. So that's why I'm using this one. And B is going to be equal to 108.6 divided by the sign of 37.3. I'm running out of space, times the sine of 24.5. And you will find that B, if you put that into your calculator, you should get 74.32 millimeters. Now make sure you're writing it for steps. At least write this part down if you don't write anything else down. If you need to cross multiply, you could. It'll give you the same answer. So you cross multiply, you multiply those two and divide by the piece left over. That's another strategy. You have a couple of different options. If you're not sure about it, just see me when you have an opportunity. Now, there is one flaw with the law of sines, and it's called the ambiguous case. Now, if something's ambiguous, we would say, well, it's not clear, okay? If I said the rules around COVID have been somewhat ambiguous for retailers, I'm just meaning that they're not clear. They could be interpreted two ways or more. I think most of us could agree with some of those policies being ambiguous, multiple interpretations. The sine law presents an ambiguous case. It has more than one solution sometimes. Now, when are those times and what are those times? Well, in this particular triangle, the image is drawn. This is taken from your textbook. It's an image that I really like. A triangle has a 1.5-inch side, a 2.5-inch side, and an angle of 23 degrees, which is opposite the 1.5-inch side. Which triangle is correct? Oops, that should be not a 23, that should be a 32. Sorry. It's one of my dyslexic moments. I flipped it. So 32 degrees here, okay? You know that this side is 25, or 2.5 inches rather, 2.5 inches attached to the 32 degrees, and opposite 32 degrees is 1.5 inches. So we could draw this triangle with 1.5 inches pointing this way, or you could rotate it, pivot it until 1.5 inches hits this horizontal line from the other side. So is it the big triangle? I'm just highlighting in red. Is that the right triangle? Or is the green triangle the right triangle, which is the one inside? They both share the same angle. They share one side that's the same, two sides that are the same length, but we don't have a way of identifying which one is right. So there are going to be certain times when you could have two solutions, and we do need to watch for them a little bit. Jumping back and forth between slides here with a sensitive mouse. All right, how do we know? So there's conditions for an ambiguous case. The only time you'll have an ambiguous case with the sine law is if you have two sides and there's an acute angle in between. So acute means, remember, acute is less than 90. Okay? So less than 90 in between. And the other condition is the opposite side. So here's my angle. The side opposite is shorter than the one adjacent that is given. So if you're looking at the two sides, 32 degrees, 1.5 is opposite, and it has to be shorter than the other side connected to the angle. How do you know which one to use? Well, you use the diagram to identify the solution. Sometimes you'll get a solution, and maybe you'll get a solution of 62 degrees, and you know based on the picture that that angle has to be larger than 90. Well, if that's the case, that means you probably have an ambiguous case and you need to adjust the angle. Well, how do you do that? It's really easy. We're going to do 3 examples with it. So if you go, this is a little bit ambiguous. Nope, get a good old pun there. If it's a little ambiguous to you, figuring out the ambiguous case, hopefully the examples will make them a little clearer. So why doesn't your calculator give you the right angle? Well, your calculator will always give you an angle that's less than 90. But in an ambiguous case, we have to calculate the supplement. Now, one thing to test in your calculator is just in your calculator, take a second and type in sine of 120. So it's a really good example. So 120, press your sign. And for a decimal, we get 0 decimal 8660. And you get a bunch more decimals. In your calculator, do sine of 60. You get exactly the same number. That could be cool, that could be confusing. The reason they're the same number is because if they were right angles, if they were right triangles, they would have the same distance, horizontal and vertical. Okay, so that's where this comes in, is they could make a right triangle with the same angles. Then maybe that makes it even more confusing. But basically, because their sine values are the same, we can't differentiate between the two unless we have a picture. So how do you figure it out? All you do is you take 180 degrees and you subtract. If you know something can't be 60 degrees because it's a bigger than 90 angle, you take 180 degrees and subtract the angle you get in your calculator, because your calculator will always give you an angle that's equal to or less than 90 degrees, always. And then you have to adjust the angle after. All right, so we're going to do a couple examples with it. I don't think you'll find it too bad. Biggest thing is if your drawing shows you have an oblique angle, oblique means greater than 90, you will need to calculate what's the supplement in order to have the right angle for the sine law. Prime example is here. So if we look at this diagram, we have a triangle, and we can tell that this angle is bigger than 90 degrees. So it is oblique. We're going to get an example of the ambiguous case. How do we know? Well, this side angle, we have an angle, it's acute. An opposite is less than the side attached to the acute angle. So you will have, has 2 solutions. The correct solution is the one with the oblique angle that matches the picture for angle X. Okay, so you have 2 solutions. You could draw a triangle that looks more like this as well as the larger one. Okay, so let's do our calculation. I want to figure out what is angle X. So we're going to put this angle on top. So the sine of X divided by opposite of X is 275 is equal to the sine of 28.17 And then we're going to go opposite that, which is 140. Putting that in our calculus, and rearranging it, you're going to get sine of x is equal to 275 times sine of 28.17 divided by 140. Put that in your calculator, see what decimal you get. The sine of x is equal to, it might take you a minute, but if you do, if I'm going to the next one too quickly, just hit pause, 0.9273. To find x, we use our shift sign again because we're looking for the angle. So we're going to do inverse sine of 0.9273. And for an angle, we get 68.02 degrees. Now look at the picture. It doesn't match. Okay, so it doesn't match the picture. So that tells me, okay, either I calculated wrong or I have one more step. So because that angle is smaller than 90 degrees, and we've used the sine law, it's an ambiguous case that would have two answers. So the other possible solution for this is going to be 180 minus 68.02. Okay, so the angle that we calculate, we have to subtract from 180 to correct it. Basically, we're making an adjustment, and we get 111.9 degrees. Here's my peachy notes here. All right. Okay, so it's not hard. You just have to look at the angle and then look at the picture and go, is that bigger than 90 or smaller than 90? If it's bigger, or you look at your picture and go, is that bigger than 68? Well, of course it's bigger than 60. It's bigger than 90, so we know we have to calculate the supplement. So you do 180 minus 68.02. And that gives us our angle. And this angle is larger than 90, which lines up with what we would expect. Okay? The only way you can tell which answer is the correct one is if you have a diagram. So the diagram is going to be really important for that. More often than not, you won't have multiple solutions possible, but logic in a diagram is going to be what tells you which one is correct. But anytime you calculate an angle using these sine ratios, where it's sine over side equals sine over side, you will need to kind of look at your diagram and double check that that answer lines up. Okay, here we have another one. It says, could the information this triangle drawn be used to give another solution? I'm missing some letters and words in there. If so, what would the other angles be? So this one gets you to think, well, what are the conditions? So conditions. I need an acute angle. Do I have an acute angle? It's less than 90. I've got that condition. Second condition. Opposite has to be smaller than the adjacent. Okay, so the opposite is 6 and adjacent is 4.5. So there'll be 6 has to be less than 4.5. That's not true. So this isn't met. There's only one solution. We can't rearrange this side to give two triangles no matter how you try. So all I do is I look at the angle that I know and I go opposite it. Is that longer or shorter than the one that's next to it? So this one's only going to have one solution. And since we're here, let's do the calculation on it. I didn't leave a lot of space here. But we should be able to calculate. It's just a really good example. So to calculate this one, let's first we need to calculate some sides. So this side would be big Y. This is going to be big X. And let's call this one, let's call, oops, not, that's going to be here. Let me just erase here. All right, so if this is big X, this side's little x, and let's call this Z, and we'll call this one little z. Okay? All right. So now that we have that, we'll calculate our sides. So let's just line up our pairs. Remember that the match letters always match with each other. So as we calculate, let's find, it doesn't matter which one you find first, let's find x first. So sine of x divided by side x is 4.5 has to be equal to, what's a pair that we know? So a pair that we know, I know side z and I know angle z. Okay, so it's going to be sine of 63 degrees, 50 minutes. And you can just put it in your calculator for 63 degree minute second button, 50 degree minute second button, and then press your sign. It will use that information. You don't have to convert it, which is really nice. It saves us some time. And then 6 on the bottom. We're going to get sine x is equal to sine of 63 degrees, 50 minutes, divided by 6 times 4.5. And you should get a decimal answer. That decimal will be 0.6731. To find x, we do shift sign. So remember, this is the sine of x. So you have to do that shift sign to get the inverse sign and then put in that decimal number. If the decimal's already in your calculator, you don't have to type it in again, just do shift sign. And you get x, angle x, is equal to 42 degrees, 19 minutes. So if you're not sure about the 42 degrees, 19 minutes, you're going to get a decimal and just press that degree minute second button, and that will put that into degrees and minutes, because if your question gives you degrees and minutes, you should answer in degrees and minutes. Now I know I went to 42 degrees, 19 minutes. The reason I rounded that way is because it was 42 degrees, 19 minutes and 34 seconds, I believe. And the seconds are over 30, so it would round up to the next minute. You could include your seconds if you would like. So that's our angle x. Angle y, or angle 1, is easy to calculate. It's just 180 minus 63 degrees, 51 minutes, minus 42 degrees, 19 minutes. And you would get 73 degrees, 51 minutes. And you can do that all with your degree minute second calculation. So pretty easy to do. Lastly, so we have this piece, we got the angle x, the last piece is to find side. Find side y. So y divided by the sine, we just got that angle, 73 degrees, 51 minutes, is equal to side z, so 6, divided by the sine of angle z, which is 63 degrees, 51 minutes. And I'm just going to give you the answer here because I'm out of space. I'm going to see if, just take a pause for a minute, see if you calculate and get the same information. It's just a practice rearranging. So you should get y is equal to 6.421 inches. So the same kind of rearranging as before. This time you don't use shift sign because you're looking for a side. So that shift sign is only when you want to find an angle. I have one final question for you, and we'll do that quick calculation. One more with the sine law, and of course, I've included an ambiguous case, even though I said ambiguous cases tend to be rare, but I just want to give you another example with it. A triangle has a 4-inch side, a 5-inch side, and a 37-degree angle opposite the 4-inch side. Could it have more than one solution? If yes, calculate the angles for both triangles. So, okay, so what we're looking at is, we've got to first of all look at the conditions. So condition 1, we need a acute angle. And that one is met. Condition 2, And we may need a sketch for condition 2. So condition 2 says opposite has to be less than the adjacent. ADJ. We'll abbreviate it like that. So let's sketch our triangle to see. So we'll just assume it's going to look like this. And we'll see what we're going to find out is we're going to find out, could it instead look like that? So which version of the triangle is possible or are both possible? So here we'd say we'll say this angle is 37 degrees. It says the opposite side is 4 inches and this is 5. So opposite 4 has to be less than 5. That's true. So yes, you could have 2 triangles. All right, so we met both of the conditions. One of the ways you can tell, if you think maybe you would have 2 solutions and you go to calculate it and it's impossible to have 2 solutions, the second triangle will have more than 180 degrees, which is impossible. You can never have a triangle with more than 180 degrees, so you can use that as your check if you're trying to figure it out. If it wouldn't make sense if your answer doesn't make sense in that your triangle would have more than 180 degrees, you know there's only one solution. So there is more than one way to figure it. So the other possible triangle would be 37 degrees here. And I'm going to put it this way, 5 inches there and 4 inches here. Still opposite and adjacent, okay? So then it says to calculate what are the angles. So in order to calculate it, 37, we want to find out what's this angle over here. Okay, I'm going to call this one B and I'll call this one A. So let's see. Triangle, I've just flipped it upside down. Maybe it will help. Actually, I'm going to, just for the sake of making it look the same, this might confuse some of you if I change it up. Other triangle we can have is 5, 4, like this. So 5 inches, 4 inches, and this would be 37 degrees. That maybe is a better picture. This is B. In this case, B is bigger than 90. In the other situation, B is less than 90. So it's pretty easy to calculate. So the sine of B divided by 5, because it's opposite of B, is equal to the sine of 37 divided by 4. Easy ratio. Rearranging it. Sine of B is equal to 5 times the sine of 37 over 4. Putting that into your calculator, you'll get 0.7523, and B is going to be the inverse sine. So we're finding that angle. So that's the shift sign option, and you will find B is 49 degrees. So this would be 49 degrees. Now 49 degrees can't work down here. So for this example, I do 180 minus 49, which is 131 degrees. Okay, and that would give you your angle. And then up at the top, in this case, let me see, what would the angle be? This one would be 12 degrees because you just do 180 minus 131 minus 37. And angle C in this one would be 94 degrees. 180 minus 49 minus 37. So the ambiguous case isn't really that bad, and they're quite rare to show up, so you won't see too many, but just kind of pay attention. Could it be possible, and where would it be? And you're only likely to see one example of that, not anymore. And that concludes the last piece of trig that you're going to do in terms of new information. Next week, we'll spend some time doing some, next week or when we're back in class, we're going to do some review and an assessment or a little project with our trigonometry.